Okay, everyone, yesterday we learned how to sketch and familiar graphs. Okay, so to sketch a familiar graph, we need to find domain, xy intercepts, find its stationary points, state the nature, think about the general shape, and find the behavior of y values when x approaches infinity and x approaches negative infinity. Okay, and we not finishing example 1 part B yet. Yesterday we just find the first one is the domain. We know the domain is that. And then we find the stationary points. Okay, we find the stationary points, which is this point, and that's a turning point because of this table. And I said to choose the value wisely, and you can calculate the numbers. Okay, you can calculate the numbers and easily find out it's positive or negative. And we find out that's a minimum turning point. Okay, we find out it's a minimum turning point. Okay, the next thing what we need to do is find the xy intercept. Okay, there won't be y-intercept because your x cannot be 0. Think about the domain. Your x cannot be 0, so you can't have a y-intercept. Okay, no y-intercept. And think about the x-intercept. So when y equals to 0, so when y equals to 0, x times log e to x, x times log e to x, that is going to be 0. Then is either x to be 0 or log e to x to be 0. But x cannot be 0, okay, because of the domain. X cannot be 0. We use non-factor law to say either this is 0 or that is 0. But actually it's not 0. Therefore, I will have 2x must be 1 because log e 1 will give 0. Or you say 2x equals to e to the power of 0, that is 1. Then x is a half. So the x-intercept is a half comma 0. Okay, a half comma 0. First, no y-intercept, and you have x is a half comma 0, and you have a minimum turning point at that point. Okay, that point. Okay, let's think about the behavior when x approach to infinity. When x approaching to infinity. Okay, think about this function. This function is x times log e to x. Okay, that's two function times together. Let's think about the behavior for this one. Okay, x approaching to infinity, that value must approaching to infinity, right? And think about log e to x. When x approaching to infinity, log e of a really big number, what's this graph looks like? The graph looks like that, right? It's a log graph. When x approaching to infinity, log e to x must be approaching to infinity as well. Okay, a really big number times another really big number, what's y value approaching to? Infinity, right? Finally approaching to infinity. So y will approaching to infinity. Okay, next. When x approaching to 0, I'm not going to approaching to negative infinity because it can't really go negative infinity. The end point is 0. You want to think about what will happen at that point. Have a guess what the y value will approaching to when x approaching to infinity. I'll ask you first. A number times a really small number, what that will become to? Like 10,000, okay? Maybe not 10,000, like 100 times 0.000000001, what that will become? Approach to 0. Okay, approach to 0. Okay, let's have a look at this. This value x, okay, is approaching to 0. Okay, it's closer to 0, which means it's getting really small, right? Really, really, really small when they're approaching to 0. And think about this number. It doesn't matter what this number will really like go to 0. Let's say graph is here. When it's approaching to 0, that will become like negative infinity. But any number times 0 will become 0, right? Any number times 0 will become 0. Even though this part has a really big negative number. But don't forget, this part get really, really, really tiny. Like a really big number times really tiny number is still approaching to 0. And also when the x is actually equals to 0, this thing will just become 0. Okay, nothing here. So when x is approaching to 0, your y value needs to approach 0 as well. Okay, get closer to 0. Okay, get closer and closer to 0. Okay, let's have a think about what's the shape of this graph. Okay, first you have a half and 0. Let's make it here, a half and 0. And then you have one turning point. Where's the turning point? The turning point is 1 over 2e. Do you think 1 over 2e is greater or bigger than half? 1 over 2e is greater or bigger than half? Smaller sign or greater sign here? Smaller sign. Okay, so this number is to the left of that point. Let's say, I don't know where exactly is that, but I'll say that's here. That's 1 over 2e, comma, negative 1 over 2e. Is that negative? Yeah. Okay, that should be what? That should be a turning point. Okay, a minimum turning point. Okay, let's say a minimum turning point will look like that, and it will go positive infinity when x gets to infinity. Okay, let's have a think what this part will become. You only have graph to the right? Okay, turning point must look like that, and it must go through this point and go to infinity. So how about this empty part? What's the graph will look like? If there's asymptotes, how you can show approaching? It's not approaching. Okay, you can't extend to here. So what the graph will look like is an open circle and that. Okay, an open circle and that. Because the only point I can't take is that point. Okay, the only point I can't take is that point. And all the other points I can get a value. Okay, I can get a value. So the only thing I can't have is this point here. So you need to label 0, 0 as well for this point. Okay. Have a look at example 2. Okay, have a look at example 2. The curve with equation that pass through 0, 5 with stationary points 2, 7. Okay, with stationary points 2, 7. What that can give you, stationary points can always give you two pieces of information. One is f2 will be 7 and one is f-2 will be 0. It always give you two pieces of information. And pass through 0, 5 always give you the constant and the c value is 5. Okay, so y equals to x cubed plus ax squared plus bx plus 5. dy dx equals to 3x squared plus 2ax plus b. Okay, you can set up two simultaneous equations by using these two pieces of information. So F2 gives you 8 plus 4a plus 2b plus 5 equals to 7. F-2 is 0. So 3 times 4 plus 4a plus b equals to 0. What I have is 4a plus 2b equals 2. Okay, 7 minus 5 is 2. 2 minus 8 is negative 6. And that one gives me 4a plus b equals to negative 12. Okay, let's use the top one minus the bottom one. Okay, 1 subtract 2. 1 subtract 2. 4a minus 4 is 0, and 2b minus b gives me b. b equals to, okay, 6 minus negative 12. What that is? 6, yeah? Negative 6 minus negative 12 is negative 6 plus 12. That gives you 6. So b is 6. If b is 6, then what is a? So 4a equals to minus 12 minus 6 is minus 18. Okay, so it's minus 18. A equals to negative 9 over 2. So therefore y equals to x cubed minus 9 over 2x squared plus plus 6x and plus 5. Anything wrong? No? Okay, example 3. Example 3. The displacement x meters of a particle moving in a straight line is given by x equals to 16 minus a third t cubed for t in between that time, where t seconds is the time taken. Find the maximum displacement. Okay, find the maximum displacement. Let's say the maximum displacement, like, let's say where it occurs first. Okay, can I just sketch this graph first? So I have x equals to minus 1 on 3 t cubed plus 9t. X will equals to minus a third t bracket t squared minus 27. X will equals to minus a third t bracket, okay, 27. You have t squared minus 3 root 3 squared. X equals to minus a third t plus 3 root 3 and t minus 3 root 3. So that's a cubic graph. You have t and x. You have positive 3 root 3, negative root 3, and 0. And this graph must start from the bottom right, okay, right bottom, because it's a negative leading term. So it will go through this hole, go down here, and go back here. Okay, that's the shape of this graph. And the domain, where's the domain? The domain is in between 0 and 3 root 3. Okay, 3 root 3 is from here to here. Okay, from here to here. Okay, that's the green part is this graph. So, okay, You can do without drawing this graph, okay? But like I want to show you this, the full thing here. A little bit revision for polynomials. I know now is the displacement maximum displacement is the turning point. So I'm trying to find the turning point. How do we find turning point? How derivative equals to 0. So dx dt equals to 9 minus t squared. Okay, 9 minus t squared. And 9 minus t squared equals to 0. T squared equals to 9. T equals to plus minus 3. T is greater or equals to 0. So t equals to 3 will be the only solution. Well, I haven't shown t equals to 3 is the maximum turning point. Yes, you definitely know it's the maximum turning point because of this graph. But if you haven't sketched this graph, you can't say that's the maximum point. It can be a point of inflection, it can be a minimum turning point. You don't know. Okay, you need to test it first. So how do we test this? We test it by sketch this table. Have 3 in the middle. You have t values, dx dt values, and you have the graph. You choose a point 1, you choose a point 4 to see the derivative. So when x equals to 1, dx dt equals to 9 minus 1, which gives you 8. When t equals to 4, 9 minus 4 squared is 9 minus 16, which is negative 7. So 8 is actually positive or negative, right? So you have positive, 0, and negative. That's a maximum turning point. But you haven't answered the question yet. Okay, you haven't answered the question yet. It asks you what is the maximum displacement. You find out the time to give you the maximum displacement. You need to find the actual displacement, this y value here. Okay, this y value here. So what you do is when t equals to 3, x will equals to negative a third times 3, that's a negative 1, and 3 squared minus 27, that's 9 minus 27 is negative 16 times negative 1 gives you positive 16. It gives you positive 16. 9 minus 27 is negative 18. Okay. Okay, it's 18. So it's the maximum. It's the maximum displacement. Okay, that's the easy case of displacement and velocity. And you not really talk about velocity at all. Okay, not talk about velocity at all. It's just talk about how to find the maximum point of a graph. Okay. Okay, example 5. Example 5 is important. Okay, that's one type of question always appear in VCA exam in the multiple choice. Okay, in the multiple choice. Classify like all the type of questions for VCA exam. I will show you after we finish the course. I will tell you what type of graph is what proportion in the VCA exam for the past 10 years. Okay, so you can see all the type of exams. Okay, you can see all the type of exams. So this is one type of exam that always appear in the multiple choice. It's not worth you to do any work, like to give you 2 marks. So it's a 1 mark question, but it's a quite important thing. It's a key point. So example 5 is sketch the graph of a function with rule y equals to fx. Given that f1 equals to 32, f5 equals to 0, f0 equals to 25. Okay, they're all like this. Gives you the x-intercept, that gives you the y-intercept. That just gives you a random point. the important thing is the derivative they give you. They said derivative is f dash x equals to 0 when x equals to 1 and 5. Okay, that is the most important thing. That can tell you what is the shape of your graph. So let's sketch this table. Okay, we work back from this table. I'm not sure if there's enough box. So the first one is empty, and you write the first stationary point, which is 1. Leave 1 empty, and write the second stationary point, which is 5. Okay, good, enough box. So f dash x, and you have the graph. So the derivative is the thing can gives you the shape of the graph. Okay, when x equals to 1 and 5, that equals to 0, so those 2 points are 0. Okay, those 2 points are 0. And then the next thing you know is f dash x smaller than 0. Okay, f dash x smaller than 0 when x is in between 1 and 5. Okay, your f dash x is negative in between 1 and 5. Okay, that is a negative. F dash x is greater than 0 when x is smaller than 1. Okay, smaller than 1 and greater than 5. So those 2 places are positive. Okay, so what's the shape of the graph? It's quite obvious. Increase 0, decrease 0, increase. That is the shape of the graph. Okay, and also you know that at f5 equals to 0. That is f5 equals to 0. It's also the minimum turning point, and it is also the x-intercept. So you have 1, 2, 3, 4, 5. Let's say it's here, and it's a turning point. Well, I shouldn't do this like let's do here. 1, 2, 3, 4, 5. Let's say 5. F5 is 0. Okay, let's have a look. F1. Okay, F1 is 32. Okay, F1 is 32. So the maximum point. Okay, F1 is here. That's 32. So 1 is here, and that gives 32. The shape of the graph is like that. And that's the maximum turning point. And F0 is 25. So at 0, 25, 1, 32, and you have that point is 5, 0. Maybe it's not a nice shape, but roughly the graph looks like that. Okay, so from this table you already know what's the shape of the graph, and then you're trying to fit with the points. You're trying to fit with the points. So there are always questions like that. They give you, okay, f dash what equals to 0. Okay, give you 2 or 3 points and tell you what can give you 0. And then it tells you, well, from here to here it is positive, from here to here is negative, and what's the shape of the graph. That's one type. Okay, word description. There's another type. Okay, there's another type. Where's my, it's not here. One minute. There's another type. Another type is give you the graph. They tell you that's an x graph and that's an f dash x graph. Okay, this is a little bit harder than the previous type I give you. So let's say we have Let's say we have a graph like that. That point is -2, 0. That point is 3, 0. And that point is 1 and 10. And that point is 0, 9 or 8. And they ask you to sketch the shape of the original graph. The shape of the original graph. Tell me what are the, like there are 4 points labeled, right? 4 points labeled. What are the important points? How many points are useful? 1, 2, 3, or 4? 2, okay? Only this one and this one is useful. The other two, just don't look at it. There's nothing to do with this. Okay, it's a f-x graph. If a f-x graph, I only care about what is the 0 values. Okay, what x value can give me derivative equals to 0. So it's -2 and 3 gives you derivative equals to 0. And then you use that to set up the table. Okay, so you have x, f-x, and the graph. So the point is -2 and 3. So let's have -2 and 3 right here. -2 and 3 will give you derivative equals to 0. And let's have a look to the left of -2. Is that the gradient positive or negative? Positive. Okay, you don't think about the trend of the graph. You just see above x-axis or below the x-axis. It is positive. You have gradient positive to the left of -2. You have positive. In between -2 and 3, is that the gradient positive or negative? Positive. After 3, the graph is positive or negative? Negative. Then just complete the graph. Positive, 0, positive, 0, negative. Can you see that the -2 gives you a stationary point of inflection and the point 3 gives you a turning point and it's a maximum turning point? Okay, if I can sketch this graph must look like that. Okay, that point must be -2 something. I don't know what is it. And that point must be 3 something. Don't know the value. It's not accurate, but the shape of the graph is roughly like that. You have a stationary point at x equals to -2, and you have a maximum turning point at x equals to 3. So should be really careful when you see a graph, whether it's the original graph or it is the f-x graph. If it's the gradient graph, you need to sketch your original graph by this way. Okay, there will be 2 types of multiple choice questions. One is give you the original, ask you to find the gradient, and that's easy. The other one is give you the gradient function and ask you to find the original. That will be this type, and it's a little bit harder. Give you a couple of minutes to finish up. That's exercise C and D. Well, in my notes, I put application of differentiation of kinematics, the velocity acceleration thing. I'll go through a little bit. But that's not all of it. Antiderivative also play an important role here. So it's half of this. But let's have a look at the absolute maximum and minimum values and the maximum minimum problems. So for this type of question, like the problem, okay, the problem for we have in this chapter is when you see wording questions and give you an equation, you don't know whether the turning point is the real maximum point or the end point is the real maximum point. Okay, so you have a graph like this. Obviously, that point is larger than the turning point, but when you find the derivative, you can only find out that point, not the end points, right? So you need to test whether the end point is higher than the turning point or the turning point is actually the absolute maximum. So this is about absolute maximum or local maximum question. You need to always keep this in mind. Okay, have a look at example 1. Have a look at example 1. So giving you a relationship x plus 2y equals to 4 and calculate the minimum value of that equation. Okay, the minimum value of that equation. You want to find the minimum value, so you need to set an equation first. There's no equation for that thing. So let's say let capital A equals to x squared plus xy minus y squared. A is the value of that equation. Okay, A is the value of that equation, and you want to find what? You want to find the minimum A. Okay, you want to find the minimum A value. So from x plus 2y equals to 4, you know that x equals to 4 minus 2y. You substitute back into that. I don't want two variables, okay? I don't want two variables. So I will have 4 minus 2y squared plus 4 minus 2y times y minus y squared. That A equals to 16 minus 8 times 2, 16y plus 4y squared plus 4y minus 2y squared and minus another y squared. A will equals to y squared minus 12y, which is those two, and plus 16. And plus 16. Okay, A and Y is a what relationship? They are in that what equation is that? What graph? Problem. Okay, so and it's a small face problem. You have a turning point, a minimum turning point. You definitely get a minimum A value. So instead of using the derivative to find the turning point, you can just find by completing square, find the turning point, and you know that is the minimum value. Because it's a quadratic, you know you can predict the shape of the graph, and you know what is the actual value. So A will equals to y minus 6 squared minus 36 plus 16. A equals to y minus 6 squared minus 20. So A minimum equals to minus 20. Okay, when y equals to 6, that whole thing will give you a minimum value, which is negative 20. Example 2. Okay, a shelter is made up with a back a back, 2 square side, and a top. So 4 faces, okay? So a back, 2 square side, and a top. So the area of that is 24 meters square. Okay, the whole 4 piece is 24 meters square. Let V be the volume, okay, enclosed by the shelter. Find the dimension that will create the largest possible enclosed volume. Okay, so first, for this type of question, we need to set up XY relationship first. Okay, for this type, when you see 2 variables in the graph, you always need to set up a relationship between X, Y. So what's the relationship between X and Y? For X and Y, they're talking about the area. So one thing which is fixed is the area. Okay, one thing which is fixed is the area. The area is 24 meters square. So what's the area? So for the 2 square, you have 2x squared is the 2 square sides. And you have a back and you have a top. So the top and back is actually with same length and same width. Okay, the width is OX and the length is OY. Plus 2XY. That gives me 24. Okay, those 4 pieces add together must gives me the 24 meters square. Okay, the area is fixed. So what Y equals to? 2xy equals to 24 minus 2x squared. Y will equals to 24 minus 2x squared over 2x. Y will equals to 12 minus x squared over x. Okay, first, tell me what, well, that's the next question. I will keep it to the next. Okay, that's the relationship between X and Y. And how can we find the volume of this thing? The volume equals to the space, area of the space, base times the height. So let's treat this as the base. So it's X squared as the base. So X squared times Y, height is Y. Let's make it vertical. X squared times Y is the volume. So V equals to X squared times 12 minus X squared over X. V will be minus X cubed plus 12X. Okay, that is 1. That becomes X is minus X cubed plus 12X. What I want to find the dimension of the shelter which create the largest possible volume. Okay, largest possible volume. Let's think about the X. What X can take? What is possible X? First question, can X be smaller than 0? Okay, can X be equal to 0? No, okay, because first denominator here can't even equal to 0. So X needs to be greater than 0. Okay, X needs to be greater than 0. Okay, then can X be, can X be too large? Why not? Because the surface area is fixed, right? The surface area is fixed, so you can't make it too large. So what is too large? Let's say 2x squared. Okay, your x will decide on the 2 side, the 2 square. Okay, the 2 square needs to be smaller than 24. Do you agree with that? You need to at least left something for the middle 2 part. Okay, the other 2 things. So your 2x squared, which is the 2 area for here and here, those 2 areas shouldn't use up all the areas. Okay, shouldn't use up all the areas. So that needs to be, x squared needs to be smaller than 12. Okay, x squared smaller than 12. So x squared is here. Okay, 12 is here. That gives you negative 2 root 3, and that gives you positive 2 root 3. So it needs to be below than 12. Your x needs to be in between those two values. And also you know that your x needs to be greater than 0. Therefore, your x needs to belong to 0 to 2 root 3. Okay, in between 0 to 2 root 3. It can't be too small, it can't be too big. Sorry. Here? That part? Okay, so I have a think about that. If that value, okay, is less than 24, okay, 24 minus that must have some value, right? Some value divided by 2x, it still has some value, so you always have some value for y here. Like if that is not 24 yet, that must give you some space for y values, like y must can take something. Okay, we don't need to worry about y. Or if we want to think about another approach, that will be your y value needs to be greater than 0, right? Your y value needs to be greater than 0, which means that whole thing needs to be greater than 0. You can solve the inequality for that, which your x cannot be 0 and your x is positive. So you can directly times x on both sides. What gives you is 12 minus x squared greater than 0. You're trying to solve that greater than 0. That will be the same you solve for that. Can you see? 12 minus x squared is greater than 0. You'll be the same, like it's different. It's not the same thing. Okay? You solve for that or solve for that will be the same. Okay, so sketch the graph. Well, I haven't found the maximum point yet, so let's find dv over dx. It's minus 3x squared plus 12. You want to find the turning point. You want that to be 0. Then x squared needs to be 4. X needs to be plus minus 2. Okay, x needs to be plus minus 2. If your x is plus minus 2, can't be minus 2, okay, because x belongs to 0 to 2 root 3, so your x needs to be positive 2. And you don't know whether it's the maximum or minimum or the point of inflection. You need to test for that. You have 2, you have 1, and I have 3. What's 2? Okay, 2 root 3 is greater than 3. Okay, 2 root 3 is root 12, and 3 is root 9. So 3 is to the left of root 12. So I can put 3 here. And that is 0. So x dv dx and the graph. Okay, put 1 in dv dx. Minus 3 times 1 gives you minus 3, and that's a positive. And put 3 in dv dx. Minus 3 times 3 times 3 is minus 27, and that's definitely a negative. Positive, 0, and negative, that gives you a maximum value. And that gives you a maximum value. And what the question is asking is find the dimension of the shelter will create the largest possible volume. I'm not asking you the volume, I'm asking you about the dimension. So if x equals to 2, that will give you the maximum. So the dimension is x equals to 2. Then what y will equals to? If that's 2, y should be 4, I reckon. So when x equals to 2, y equals to 12 minus 4 divided by 2, 8 divided by 2 is 4. Okay, y will be 4. When x is 2, y will be 4. So the dimension is x equals to 2, y equals to 4. Two more parts. Go to part B. Part B is sketch V against X for a suitable domain. For a suitable domain. Can you see this shape of the graph? Is like this shape. So for the suitable domain, that will be the shape of this graph. Okay, that's 0, 0. That's 2 root 3, 0. And for that point is 2, comma, okay, I need to find the v value. V equals to minus x cubed plus, where's my v, 12x. When x equals to 2, v will equals to minus 8 plus 24, v equals to 16. So 12, 16 is the turning point. Okay, you know, like v will equals to minus x squared, x minus, where's my, minus x, and x squared minus 12, v equals to minus x, x plus 2 root 2, 2 root 3, and x minus 2 root 3. Okay, that's the whole graph, look what it looks like. Okay, if you want to complete a full shape of this graph, the graph will be somewhere here and somewhere here. Can you see the really light? See? That's the full shape of this graph. You have negative 2 root 3, have positive 2 root 3, you have 0. The graph is a negative graph. Start from here, your graph looks like that. But because of the domain is 0 to 2 root 3, you only have this part of the graph. Don't have here, don't have here. So turning point is when x equals to 2, find the v equals to 16. So 2, 16. That's the shape of the graph. Okay, for C, find the values of x and y when v equals to 10. When v equals to 10. minus x cubed plus 12x equals to 10. X cubed minus 12x plus 10 equals to 0. Okay, we want to solve for a cubic. Want to solve for cubic. Okay, how do we solve for cubic? We need to factorize that. I use this method. I'll try a value 2. No, that's not going to work. Okay, we try some values. Yeah. Minus. Here. Let's rethink it then. That's 2. That's not going to work. 5, 1, 5. 5, 25. That's too big. Well, I think we should use CAS to solve for that. Wait, let me think. 5 is not working, negative 5 is not working. We can solve that later. I will